Trinity and Vangai are practicing through balls so they can be better when game time arrives. Vangai wants to receive the ball at the corner of the 18-yard box. She is the winger who is making the run. Trinity is the midfielder who will play the ball. They start at the halfway line, but Vangai is 48.23 feet east of Trinity, facing north towards the goal. Vangai starts running towards the corner of the 18-yard box. Trinity hasn't played the ball yet. He will play it when Vangai gets closer to the spot. However, halfway to the destination, Vangai stops.
I wonder the rate at which the distance between me and Trinity is increasing. I learned how to do this in AP Calculus.
So this is a visual of what we know. Here's Trinity at the halfway line, and here's Vangai, halfway to the corner of the 18-yard box. A triangle forms, a right triangle. We need to figure out the lengths of these things and show everything that we know so far. So we're going to call this length A. So A, when we measured it out, was 48.23 feet. We're going to call this B. B, when we measured it out, was 48.12 feet. To figure out C, we're going to have to do the Pythagorean theorem. So we're going to do it here. So A squared plus B squared equals C squared. 48.23 squared plus 48.12 squared equals C squared. This answer ends up being 4641.67 equals C squared. Square this, and C equals 68.13 feet. So C here equals 68.13 feet. Now we have to figure out the derivative of each length in respect to time. So we're going to write it like this: the derivative of A with respect to time. This is always going to be 0, the derivative of A with respect to time, because no matter whether Vangai is here or here or here, this length is always going to be the same. This length is not changing. So this is 0 feet per second. The derivative of B with respect to time equals the rate at which Vangai is running, or how fast she is. So she's running 20 feet per second. And then here, this is what we're trying to find. We're trying to figure out the rate at which this length is increasing, the distance between Trinity and Vangai. So this is derivative of C with respect to time, and that's what we're trying to find. So to figure that out, we're going to use the Pythagorean theorem again. So we write out the Pythagorean theorem. So we take the derivative of A squared, which is 2A, and then we'll multiply that by the derivative of A with respect to time. And then you find the derivative of B, and then multiply that by the derivative of b with respect to time. And then you do that with c. 2c, derivative of c with respect to time. And so, we plug things in. We can cancel out the 2's here because the 2's aren't necessary. So A here, 48.23 feet times dA over dt is 0 feet per second. This is the derivative of A with respect to time. Plus B, which is 48.12 feet, times the derivative of B with respect to time is 20 feet per second, which equals 2. Oh yeah, we don't need the 2. Which equals C, which is 68.13 feet, times the derivative of c with respect to time, which we don't know yet. So now we're going to make this calculation. This is always going to be 0 because anything multiplied by 0 is 0. .12 times 20 feet squared equals 96.24, 962.4. And then 68, and then we have 68.13 feet times the derivative of c with respect to time. So we're trying to get this alone. So we're going to divide this by 68.13 feet and divide this by 68.13 feet. The derivative of c with respect to time ends up equaling, when we divide this out, 14.13 feet per second. We figured it out.
Hey.
Vangai Mutatu and Trinity Mutatu are included in this video.